Okay, I think we'll continue to have people trickling in here, but in the interest of time, I think we'll go ahead and get started. Welcome, everybody, and thanks for coming in virtually to our June Cloud Native Madison meetup. This is our third virtual meetup we've had since kind of going on quarantine here, and we obviously prefer to be able to get in FaceTime with you all, but this has opened up some new opportunities for us to actually bring in some remote speakers from some of our partners in the community, and we're really excited about that. I mean, I think it's been going pretty well so far. Got another great talk lined up today. Just one bit of meetup business before we go ahead and get started, and that is that we are going to be taking the month of July off, just because we're typically the first Thursday of the month, and obviously that lands on the holiday week. But do expect to see us back in August. August 6th, I believe, is the first Thursday of that month. And we'll be continuing our remote meetups at least until then. Obviously, we can't totally foresee how long this may continue, but, for the foreseeable future, these meetups will continue to be online. And so with that, I really want to thank Google for providing a speaker for us today. Today we have Ray Tsang, who is a staff developer advocate at Google. He loves Java, and he loves talking to other developers about all the stuff in the cloud native space, and particularly as it relates to Java. And so Ray today is going to be talking about hosting your workloads in a serverless-like framework called Knative on top of Kubernetes. With that, whenever you're ready, Ray, take it away.
Okay, all right. Thanks for having me here. Let me just gonna go present in a second and make sure I got all my IDEs open up properly. Why not? Terminate. There we go.
One other thing I forgot to mention, if you'd like to jump in and ask Ray a question at any time, I think that's totally cool. If you'd prefer to put your question in the chat functionality up in the upper right-hand part of your screen, you can do so there as well, and I'll kind of moderate that and find an opportune time to jump in and make sure those questions get asked. So feel free to ask questions as we go here, either way you prefer.
Yep. Cool. So there we go. Yeah, minimize that. Okay. Well, I should actually ask, can you see my screen?
Yep, looks good.
Awesome. Because it did happen to me in the past where I went through 3 slides and I forgot to present. So this is good. So thanks for having me here. I'm a developer advocate for Google Cloud. And what that means is that there are 2 things I really enjoy doing and that I do every day, which is to communicate and talk with the developers to show them some of the best and latest technology coming from Google, whether it's on Google Cloud or in the cloud native space, right? So things like Kubernetes, Istio, gRPC, and many other things like Knative. The other things I like to do is to listen to the developers and the users and learn about your experiences with Google Cloud and any of these technologies. So I love to hear about feedbacks. And if you have any questions, any feedback, please reach out to me. The best way to find me is on Twitter. I check Twitter more than I check email. So if you have any questions, just DM me on Twitter. I'll be able to help you. And if you want to find any other information about this session or other talks that I have, you can check out my site, which is citizen.me. Okay. And because it's the first time I'm speaking here in the Cloud Native Meetup in Madison, so I'm going to do a little more extended introduction for myself. And aside from technology, I love to travel. Unfortunately, I can't travel anywhere right now, but I used to love travel. I still love it. I just can't go anywhere. However, this photo is very special to me. As you can see, it is in the middle of sand dunes. Now, why was I there? Long story short, I was backpacking for about 4 months in Asia, and I came across this city in northern China where they didn't have a place for backpackers to stay. There were no hostels. There were nothing cheap. So they only had expensive hotels. So I had to find a place to stay. And so I asked around, and 2 different people told me that, hey, if you take a bus out to this other small village and then transfer to a car to the entrance of a desert, and then walk southwest in the desert for 4 hours, then you should find an oasis, and you can stay there for free. And I heard the word free. I asked, which bus do I take? Okay. Now, I don't know if anyone here hiked in the desert before by yourself. I can tell you it is not the same as walking on the beach, right? Even though they are both sand, but it's not the same. Because the sand here is really, really soft. It's very fine grain. And when somebody tells you to walk in the desert for 4 hours in one direction, it doesn't matter what's in front of you. You just walk in that direction. So these sand dunes, you actually have to go up and down. The sand is really soft, so every step that you take, your foot sinks in a little bit, and you have to pull yourself up and take the next step uphill. And you're carrying water. It's hot. It's dry. It was just, it was treacherous. And I was on vacation, and I thought, wow, this reminds me of, still working on a J2EE application back in the days. Well, today, it could be very well in terms of setting up a new infrastructure for that matter, because things are getting complicated. However, the end was beautiful. This is the photo I took from the Oasis, and it is a beautiful place that I was able to find, and it was awesome. And I think that this is where a lot of us, whether it's developers or in the infrastructure or doing architecture or operations, we want to get things into production. This is the beautiful place that we want to get to. However, the road to production is not always easy. And hopefully I can share, that's why I do. I like to share the stories that I have, and hopefully to get you to this production quicker, faster, and easier. So I'm going to show you a little bit about Knative, what it is, and what does it help in the bigger scheme of things. So about 5 years ago, I first started to learn about Kubernetes. I started to present about Kubernetes. This is one of the presentation I did at DevOps, which is a Java conference. And this is also the first time that we presented a Kubernetes cluster running Raspberry Pi, right? And it was really awesome. Like we showed the pods, we showed replication controllers, that's what it was called at the time. We showed how Kubernetes responded to resiliency. When you pull one of these plugs from the Raspberry Pi cluster, the node went away, and you can see how the application recovers. That was awesome. And I can remember the joy on everyone's faces, right? Everyone who ever seen this or seen Kubernetes at work, it's like, this is amazing. This is one of the most amazing things I've ever seen. And that's how I felt initially. 5 years later, right? Everyone is starting to use Kubernetes. And of course, the full usage of Kubernetes is not that simple. Why? Because there are also many, many steps you have to take. Right, even though we love the concept in general, but once you get into the weeds of the details, now we also have these complexity that we're adding to the architecture and adding to the application development cycle. So, for example, for a Kubernetes architecture to work with your application, right, you have to set up Kubernetes. You gotta manage it. Now, if you're running on the cloud, like using something like Google Kubernetes Engine, the management is really easy, so that's okay. However, you do need to write the code. Of course, you need to write the code. You need to build the Docker container, right, or the Docker image. Now you have to write the Docker file. Now, best if you don't need to write the Docker file, if you can use a tool to do that automatically for you, like using the build packs or using a tool called Jib if you're using Java. Now, but then you still have to upload the image into a registry. And now you have to write a YAML file, lots and lots of YAML file to do the deployment. And then you need to write another YAML file to expose it to the internet. You need to install more and more things to get traffic splitting and traffic routing and more resiliency in your service-to-service communication. And then you're going to install and write more YAML files to do that. And then if you want to scale all your workload, now you have to use HPA or something else. Then you have to write more YAMLs to do that as well. And then you got to do trace and monitoring and metrics and all of these things, right? So to me, it is just stuff that we all need, no matter whether you're doing Kubernetes or not. However, this complexity doesn't really go away. It would be really nice, though, if we can have some higher level abstractions where you just write the code, you turn it into a container and just deploy. And that's really it. And this is really what I personally feel what Knative is really about. Even though when you read about Knative, they say, this is a Kubernetes-based building block for serverless workload. When I think about serverless, obviously, we still have servers in the background, right? We're running on Kubernetes cluster, so they're running on the servers. However, in my mind, when I think about serverless, it's really about two things. One is the elasticity of your application, where you can grow to as many instances that you may need to serve the traffic, but also shrink or reduce the number of instances, even down to 0 when nobody's using it. Now, some workload actually do and can reduce the instances to 0, but many workloads may not be able to do that because you have traffic all the time, right? However, in this paradigm, which is the fact that you can grow as you need and reduce the instances and free up the resources as you don't need it. The other thing is about the billing model as well. So how are you billed with serverless platforms? At the higher level, most of the managed serverless platforms, they bill at the execution times, for example. But if you're running Knative on Kubernetes, then ideally you're still kind of billed at your node and your infrastructure. However, your resources are freed up so that you can still run other applications as needed at different point in time using the same infrastructure. Okay. So what Knative does is to abstract away many of the things that we have to do manually and that we have to configure differently in different Kubernetes cluster. They really just give a much higher level of abstraction and say, this is a application service, okay? And this is how we will be able to manage your application service, how we're going to deploy it, and how we can do traffic splitting and routing for you out of the box, right? So that you don't have to manually configure these things with additional YAML files and come up with your own methodology, right? You can just use Knative and their built-in abstractions to just deploy an application. And these are a set of primitives that you can just readily use. Another really interesting aspect of Knative is that it doesn't just serve the services where you just have a simple HTTP request or gRPC request, but it can also deal with eventing. And this is pretty interesting. So you can actually use Knative to provision a broker, for example, and specify channels that's abstracted away from the actual PubSub system that you may have. And then all the events can actually be routed to Knative, and they can actually trigger and invoke the workers or the message handlers behind the scenes, so that, again, your message handling for these events are going to be more elastic as well. So for example, if there are few messages, then you have fewer workers to actually handling it. If you have many messages, then it can automatically scale out the number of workers to handle the messages. Okay, and it was also open source by Google, just like Kubernetes was originally open source by Google, and so is Istio, and so is Knative. And all of these are open source frameworks that you can use. Okay, so very high level, we're going to into a stack, and then we're going to talk about how does this actually work. Okay, so at the bottom of this is just Kubernetes. So remember what Kubernetes can do really, really well. It's able to deploy your application using some YAML file or some configuration that defines what a deployment looks like, right? The deployment has the container image coordinate that you want to deploy, and also the number of instances that you want. Okay, so in my mind, Kubernetes is a really easy and good platform to just do the general deployment of anything. And once you deployed your application, it ultimately ends up in a pod. And the pod is the atomic unit where Kubernetes can schedule your workload onto an individual machine. And ultimately, everything that you run in Kubernetes becomes a pod. Okay. On top of that, to do all the traffic routing and some traffic management, you have the option to use a service mesh. Okay. So about 2 years ago, Knative used only Istio as the only option. But nowadays, you can actually pick and choose different load balancer or service meshes to lay on top of Kubernetes as part of the Knative stack, so that it can route traffic and creating some endpoints for you, so that you don't have to configure it yourself. And then you have the primitives. What defines an application service, and how is that different from a Kubernetes deployment, right? So this is a higher level primitive that only think about a application service and what does that actually look like, or what the events look like, and how do you actually route the events across multiple orchestration across multiple services or across multiple handlers. And then finally, you can use these primitives to actually build an entire platform. And on Google, for example, we have Cloud Run, which is a platform that uses Knative underneath. If you do Cloud Run on Kubernetes engine, it uses Knative underneath. Or now you can see that this abstraction actually is really, really useful, because you can also use Cloud Run as a managed service as well, so that you may not actually need to use Kubernetes underneath, but you're just dealing with these much higher primitives when you need to. Okay, and there are many other platforms that's implemented up on top of Knative as well. such as Pivotal or VMware has Rift, and IBM has their own things, and so on and so forth. Now, before I jump into the demo, though, I want to make sure everyone kind of understand the real workings behind Kubernetes. Because if I were to do a demo and I say, hey, let me just go ahead and deploy something, right? And I can go ahead and say, kubectl create a new deployment. I'm going to deploy a container image. Somebody wrote this image, and I'm just going to deploy it. And I can just do that, right? And what this will do is to create an API call which has the payload of the configuration, the deployment configuration, and this is actually sent to the Kubernetes server, right? The Kubernetes master, and then somehow it trickles down to each individual node, and out comes the pod that we have an instance of the pod. Okay, what most of the people that I talk to, at least in the Java community, don't know is how do we actually turn a deployment into a pod? Like, how does this actually happen? And to me, my moment where I realized why Kubernetes is so good at what it does and how we can actually extend Kubernetes to do what we want is to truly understand this workflow behind the scenes. And to me, I almost think about, and don't quote me on this, by the way, but I do like to say that Kubernetes is really just an ERP system or a document management system, if you so will, right? Why do I say that? Right? It's because everything that we do via the API is really just sending a payload of a document. In this case, the document is the deployment, and we have some specification to that document. Right? And Kubernetes will get this and store it somewhere. They will store it in something like etcd, or that can also be abstracted away, but you'll store it somewhere in a document database, whatever. And then behind the scenes, there is a controller that will be listening to these documents and these updates and decide on what to do next, right? So imagine if you are actually doing a ticketing system or a document management system, it's like, or an ERP system, it's like, hey, I need to order some widget, right? I need to order 2 widgets, and then the fulfillment center or the workers behind the scenes will get this ticket and say, okay, let me type it in, and let me go ahead and create a PO, right? And then a PO document is created, and then it kind of trickles down to the next workflow where another person says, oh, there's a new PO, let me go ahead and get finance, right? And write a check. And another document is created, and so on and so forth until this entire workflow is completed. Do you actually get the widget delivered to your warehouse? It's almost exactly the same thing when it comes to Kubernetes. So in this case, we have deployment document, the deployment controller, which is not a person, but it's automated, then creates another document called replica set. In this case, its only job is to create a replica set document that really talks about how many instances do I want to have. And then a controller called the replication controller will listen to the replica set documents and say, okay, I need to have 2 instances of engine X in this case, and its only job is to create more documents, which is the pod. And in this case, it just creates 2 pods or makes sure that there are 2 pods documents created. But it doesn't actually know where to run these pods, where to run these containers. So in this document, it doesn't actually specify which node to run on. And then what happens? Another person or another controller, in this case, the scheduler, will listen to the pod and say, these pods are not scheduled, so let me go ahead and schedule it to something else. So it updates the document again and say, the first pod you go to node 1, the second pod you go to node 2, right? And at this moment, we're just talking about data here. There's nothing that's running on your cluster. And finally, on each of the node in Kubernetes, there's a kubelet. They all listen to the documents for the pod that has their node assigned. And this is where we say node 1's kubelet will be able to see, I need to run this one pod, and let me go ahead and start this pod in the containers. And once it's started, let me update the status back to the document. Okay, that's pretty much the workflow at the high level of how Kubernetes actually turn your deployment into pod. And then when you do update the number of replicas, it actually creates a new replica set, or you use the existing one, and then it increases the number of pods, and then we create another document, the scheduler gets it, the kubelet gets it, and then you start another pod, okay? Now, with all of these in mind, There's a trickle-down effect here. From a high-level document, we create something that's more granular, and then we create something else that's more detailed. Okay, and the beauty of this is that you can actually write your own resources and controllers. So rather than just dealing with deployment, you can actually create anything you want, right? And you can write your own controllers to automate this process as well. And ultimately, you can have the pod. And this is actually how all the operators work. And this is how Istio, the service mesh, work. And this is also how Knative works. So for example, I have a colleague who wrote a Kubernetes operator called Aganis. And this is a operator specifically to run game servers, okay? And so he created this project, and now they have this custom resource definition that talks about this is the high-level abstraction of a game server, okay? And here are the attributes I'm willing to let the user specify. So it becomes a definition. And then you can add validation to these CRDs. So you can say, for this field, it has to be a string, and for that field, it has to be a number, and so on and so forth. Okay. And then the user can actually follow this schema or the definition and create their own game server, right? So now we can create an instantiation or an instance of the game server by putting in the value into the right attributes. And behind the scenes, what Aganis will do is to take this definition or take this resource, this document, and it will feed it into the controller that knows how to start a game server. And then it trickles down to creating the actual deployment in Kubernetes, which then creates the replica set and then creates the pod. Okay, and this is how we can build higher level abstractions to just about any operation needs for a Kubernetes cluster. And this is how Knative Serving works as well. So this is a high level primitive where we do define new CRDs. We define new custom resources that you can write that only knows how to run your application service, which is different from a generic pod or generic container that you just want to start, right? Because a generic container can be a job, it can be a batch job, it can be some background jobs. It may not necessarily be serving, right? So Knative Serving only wants you to deploy images that's listening on a port that can serve HTTP requests, okay? And the way that it works is that you can use the Knative service. Now remember, the term service is pretty complicated when it comes to Kubernetes because you have Kubernetes service. If you use Istio, you have Istio virtual service. And then in Knative, now you have Knative service. Just remember the Knative service is the application service, is the actual application itself, okay? And with this Knative service definition, you can write something very simple, like here's the container, and here's the invar. You might be saying, wait a second, that looks just like a regular deployment. How is that different? Well, in addition to that, you can also encode some configurations, which still is part of the deployment too, like you can have invar. And every time that you deploy a new application service version, it becomes a revision, okay? And then it also creates a route for you behind the scenes. So this is where things get even more complicated, or this is actually beyond the deployment. Because when you do a Kubernetes deployment, it doesn't actually create the load balancer for you. You have to create a service yourself. If you want to expose a Kubernetes deployment to the public internet, you need to expose the service, or you need to create an ingress. But in Knative, when you say this is a Knative service, it will automatically create a route for you. And behind the scenes, it will then create a deployment. It will then create a Kubernetes service, which then deploys the replica set and the pod. And the route actually then creates the Istio virtual service for you behind the scenes, and it has all the routing rules. Okay, so let's take a very quick look at what this might look like. That is the wrong thing, and I'm going to go to the image deploy, and here we have a very, very simple YAML file where we are talking about the Knative service. Right? So the API version is very important here, and this is the service. And you have the metadata, you have everything else here, and here's the spec. And that's all it takes, right? And I'm just going to deploy a Hello World application that I created just yesterday using Spring Boot. And I'm just going to go ahead and do kubectl apply app.yaml. Okay. Oh, before I do that, I just want to show you that there's nothing wrong in my cluster right now. There's a Hello World, but I just created that. So I'm going to go ahead and deploy delete it. Hello World. Let me go ahead and apply a Knative service and see what's going on there. So I'm going to say app.yaml, and it just created the service. It also hopefully will create the pod pretty soon. Oh, I think it's already there. And we can also see that we actually do have a Kubernetes service, right? So by creating a Knative service, we did get a Kubernetes service as well. And we also have a Istio service that's created behind the scenes also. And you can see that all of these tasks that we used to do manually, individually, just to serve an application is now all pretty much automated. And finally, if I want to actually get the endpoint to this application, I can just hit this URL. So this URL mapping is automatically created for you as well. And even better, if you're using your own domain name, you can also set up TLS, of course. And every URL, every application that you deploy will automatically have the TLS HTTPS URL as well. Okay. And now I can hopefully just curl it. Now I do remember that my machine has some issue with the XIP where it doesn't actually resolve this this wildcard for some reason. So I may actually have to come here and hit it directly. Yeah. Now, if I were to do a watch on here, I'm going to use K9S, which is a really cool console tool for my for Kubernetes. Then we can see that what happened is that because I didn't really hit my application earlier, it actually just reduced my application down to 0 deployments. Okay. When the request came in, then it started a new instance for me, and now I have one instance that's serving traffic. And now I can actually see that here we can say hello, and the name is Ray. And that's very, very simple, very easy to do. And if I leave this running for a while, what we're going to see is also that it will reduce the number of instances down to 0. Okay. And once it's done that, what happens then is when there's a new request that comes in, that new request, because there's nothing serving it, that new request will be queued up somewhere. Specifically, it's queued up in something called the activator. And the activator will hang on to this request and then also starting a new instance for you. And once it validates that the instance is started and ready to serve, then you will hand off the request to the target instance, the target backend instead. Okay. So we're going to leave this up a little bit just to see that it might actually go away. We'll come back to this console later as well. Okay. So in the meantime, let me show you something else. Like I mentioned before, the traffic routing is all built in. So we also can do something like a very simple, using a very simple mechanism to actually do somewhat complex orchestration of a blue-green deployment or a canary release for your application. Okay. So for example, here we have a very simple example here. Again, this is a Knative service. Okay, right here. And what we're going to do is to first deploy a version of this container, which happens to be the blue version. Okay. And you can also name your revisions. This is important. So every time that you deploy a new configuration or a new revision of your application, you should probably name it. If you don't name it, it will give you a random name. Okay. Then it will be hard for you to refer to it back later. But you can also give it an explicit name. So in this case, I'm going to name my new deployment, my new version of the service. The revision name is going to be called blue-green v1. Okay. And then down here, what I'm going to do is to say, I will actually route 100% of my traffic to my revision blue-green v1. I'm going to shorten this to another name for me, which is called a tag. I'm just going to tag it as v1. And this is going to be important later. Okay, so you can tag it as any name. You can tag it, you can call it the latest version. You can call it the blue version. You can call it just v1. You can call it whatever you want. Okay, so I'm going to go ahead and just deploy this. And what this will do is to create a new K-service. Get that. And automatically we can see that here is the URL. Again, I bypassed all the manual configuration I needed to do in the past. And let me see if my DNS caught up here. I still didn't catch up, so that's too bad. So what I need to do then is come to the browser, and now I can see my application. It's that simple, right? And that really cuts down on many of the steps, again, by this higher level abstractions. Now, what if I want to deploy a new version of my application, a new revision, but I'm not so confident that it's going to work, right? I want to do blue-green deployment, or I want to canary release it, right? So what that means is that I want the user to continue to see the blue version, but my new version, the green version, I want to keep it in the background so I can try it out and make sure everything works. In which case, what we can do is to use Knative's built-in mechanism again. So we can say, here's the traffic split that we want. We're going to deploy a new revision. And this revision, I'm going to call it v2. And it has a new configuration, whether it's being the container image revision or the environmental variable configuration change. And I'm going to keep the traffic with 100% traffic going to the first revision. But I also want the new revision to be there, but I don't want any default traffic to route to it. Okay. And so I can go ahead and deploy this. And if I see get pods again, we should be able to see we have v1 and v2. Now, because I didn't hit v1 for a while, you can actually see it actually went away. Similarly, if the previous hello world also went away because no one's hitting it, right? But now, because my v1 went away, if I come back here and hit v1 again, what we're going to see is that v1 is going to be started again. Right? That's pretty cool. Of course, if you're running your applications using some frameworks, or like in Java, the JVM startup can take a little bit of time, in which case you can also specify minimum instances so it doesn't shut down completely to 0. You can specify the minimum instances you need for your baseline traffic, and then you can also set a max as well. Okay. But now the default endpoint is still going to v1, which is OK, because we said v2 is going to get 0 traffic. However, how do I actually get to v2? And this is where Knative also did something pretty awesome, which is that, let me see here if I can find this. If I show you the Istio virtual service behind the scenes, you can see that it actually maps every revision, or in this case, every tag to an actual URL as well. So for example, if I want to see v2, all I need to do is to type v2 in the front of my URL, and this should route me to the v2 version, specifically v2, right? If I want to see the v1 version, I just go to v1. Okay? If I want to see what the user sees, because the user does not use these prefixes, the user still sees my 100% traffic to v1. This is really useful when you want to do a quick test in production to make sure your new deployment is still OK before you ramp up the traffic. Now, let's say you do want to ramp up the traffic. What do you do next? Then you can start using the configuration here again with the traffic split. So you can say, you know what, I'm ready to increase my traffic of v2. You can do this, you can ramp this up slowly if you want to. In my case, for the demo, I'm just going to change it to 50 and 50. So let me go ahead and just do another apply. And now the load balancer in Istio behind the scenes has been reconfigured automatically. And now if I do the refresh on my browser here, I can clearly see that there is a traffic split between the two versions as well. And as you are more confident in terms of your application that's working in prod, then you can ultimately say, you know what, let's switch all the traffic over to 100%. So in this case, we can go back to the traffic here and just switch everything back to 100%. And what this will do, and of course, it's through the regular URL right here. We can see only greens. However, remember, the v1 URL is still available because it's still there. And so is the v2 version as well. Okay. And what is also really interesting is that every time that you do change your configuration, the configuration is snapshotted into something called the revision. So here we can see the two revisions that we have. And the name of the revision, this is how we do traffic splits. Okay. So when in the traffic block in the configuration here, here where we do specify the revision name, you can actually go back in time. If you still have the revision in Knative, then you can actually go back in time and say, serve revision from 2 weeks ago. And all you need to do is to change the traffic here and you can add a tag, then at any moment in time, you can go back in time and see one of the application that was running in the past. If you want to get rid of it, though, you have to delete the revision specifically. Okay, so that is a pretty straightforward view of what Knative can do. Now, again, behind the scenes, though, since it's tied up with the service mesh, what that also means is that you can tie this up with all the metrics, all the traces, and all the communication between these services. That can also be captured automatically as well. And as you can see, my blue version, just because no one's using it, so they're all being terminated right now. If I were to pin this again, we can see that the container is again creating. If I were to do a load test on this this endpoint, then what we're going to see is the load being just like ramping up, and then what you're going to see is more and more containers being created until you exhausted the resources or until you hit the max that you have configured. All right. Now, previously in Knative, they also have a functionality that allows you to do builds. So that was called Knative Build, and that functionality has since been removed. If you want to do CI/CD, that's a completely outside of Knative now. So what that means is that you still need to bring your own CI/CD components into your system so that you can CI/CD directly into Knative Serving. One of the projects that we also work on is called Tecton. So with Tecton pipelines, you can create CI/CD using Kubernetes constructs with these higher level abstractions and the CRDs, or you can use any other CI/CD that you want as well. Okay. Another thing that I learned it for myself just very recently, actually, is that rather than creating these YAML files, there's also a command line called kn. Okay, so kn command line is really just like kubectl or kubectl. I don't know what you all call it here. Everyone calls it differently, but kn is a command line for Knative. Okay, so with kn, what we can also do is to create a new service from here. So if I say kn service, I can list all the services I have. I can also create a new one. And they do have some sample here, so you can create a new service. So what this will do really is just like kubectl, where you generate the actual API payload that you want to send to Kubernetes master. Kn, when you say kn service create, it will just create that YAML file for you behind the scenes and just send it to Kubernetes, and Knative controllers will pick it up, and very quickly you get something up and running, right? So if you want to deploy your application this way, you can. So I can say kn service create and just give it the name of the container image, and everything just works. Now at the higher level platform, right? If you are to use something else like Cloud Run or Riff or anything else, they provide very similar experiences as well. And now we're dealing at the platform level where you don't really need to know about what's running underneath. All you want is to run your container, and knowing that it conforms to the Knative spec, then what we can do then is we can do something like gcloud run deploy S0 in this case. I'm going to deploy exactly the same thing, and this will actually run my application, but in a fully managed way that may have Knative running behind the scenes, right? And that's it. Oh, I guess I don't have enough credential here, so that's too bad. It also wants to have a tag here so that we can, let's see if I can do latest. I don't know if that exists. So there we go. 6. And yes. Oh, it still doesn't work. All right, that's too bad. But I think I need to figure out, I know why. Because it can only deploy applications from that has container images stored in Google Container Registry. So you cannot just run anything off of the regular Docker Hub. So for example, if I want to run this one instead, this one should definitely work. Let's see here. Let me change the container image name here. And you can choose, I want a fully managed platform in, I'm going to run on east side, and yes. And now we're doing the deployment, right? And the experience is very similar in terms of the command line that you're going to use. Just the underlying technology might be slightly different. Now, lastly, the other really interesting aspect of Knative is eventing. So in eventing, it allows you to build event pipelines right? Imagine if you are building a webhook where an event comes in, you need to do some processing with that event. Or like in the cloud, you're listening to cloud events, right? Cloud event is a new project as well. It has some defined envelope for these cloud events. So you have these headers pretty well defined in terms of the event version, the event type, and such and such. So with cloud events, what you can do then is you can listen to these cloud events. These events can be sent to a broker, okay? And the broker will just hold on to the message in like something like a channel. And then you can define these, where do these events actually come from? These events can be produced by you, or it can be coming from the cloud, like Google Cloud Platform, or it can be coming from external messaging system like Kafka or other queuing system. And these events will then be sent to the broker, and then you can actually create your services and then bind them to a trigger. Okay, so you can bind your services to listen to certain events, and then behind the scenes will set up all the routing for you. And your service is really just an HTTP service that listens to these events and respond to the event via HTTP. And all the binding and the routing will be done for you behind the scenes by Knative as well. And you can also orchestrate more complex sequence of events by using something called the sequence. Okay, I'm not going to show some of the example here, but just so you know that's there. And the reason for that is because I think many of the eventing stuff is still pretty new. And if you go to their eventing sources, there are a lot of these sources you can use, like Apache Camel source, Cloud PubSub source, right, and so on and so forth. But if you can see I do appreciate that they code the status out, because many of them are actually POC, and some of them still are under development. So just be careful when you try these things out, because I don't think many of them are actually production ready. I think a lot of them is just still being actively developed. Okay. However, what you can try is the actual event pipeline itself, right? Creating the trigger to see how that can help you in terms of dealing with asynchronous message processing and event handling. And let me just go down lastly here. So with the sequence, it's easy to show this in a diagram, because really that you have an event source that produces a type of event. And then you want that event to go to service 1 first. And service 1 will produce another event. You want that to go to service 2. And then you will do some processing, produce the result, and then send it to service 3. And behind the scenes, this is really just a bunch of YAML files. So the YAML file actually documents the sequence of the flow. But then when you deploy this YAML into Knative, what it will actually do is to instantiate many of the underlying infrastructure that's necessary for this entire sequence of flow to happen. So for example, what you might do is to, let me fix this slide here a little bit. This is actually service 2 and channel 2, right? So what it will do is to actually automatically create these channels for you and configuring the broker so that and hooking up the service with the triggers to listen to these channels, and then for the output to send to the subsequent channels. So we'll do all of these orchestration for you behind the scenes. So then you can have this fully automated pipeline behind the scenes. Okay. Now with that, I'm going to just go through a very quick demo of what this might feel like, right, when you're dealing with Knative from 0 to something. Okay. And now because I do have the issue with my curl, so this is going to be a little tough, because I do need to hit this endpoint from my local machine here. Now, the last time I did it, I think I need to do something with MDNS, something like that, I think. I don't know why, but okay, so that didn't do it for me today. But it's too bad, because for my demo to work, I actually need to be able to hit one of these services. But let's see. Why not? We have about 10 minutes left. So I'm going to start something from nothing. Okay. So what I'm going to do is to create a very quick event handler, or just an HTTP handler that will do something interesting, which is to tell whether a picture is a cat or not a cat, right? Because I think there was a TV series that had a startup idea that they're building an AI thing that's pizza or not pizza. So this is a cat or not cat. Okay. And I'm going to build this very quickly with Spring and using our ML API, for example. And then what we're going to do is to containerize it with some automated tools. And then we're going to deploy it into Knative very quickly. And we're going to show you what that feels like for this entire workflow. Okay. So with Spring, what I'm going to do is to use the Spring 2.27. Maybe I use Java 11. and I'm going to use something called Spring Cloud Functions. So this allows me to write a simple function very quickly, and that still serves on a HTTP endpoint. I'm going to use a web starter here so that I can listen to the web endpoint. And I'm going to use GCP support here so I can use our API to do something interesting. Okay, and then what I'm going to do is to change this to cat not cat. That's the name of the application. And let me put it in downloads. And let me see if I can open this. Yeah, hopefully it's there. Okay. So we can bootstrap a very small application here, and this happens to be a function using Spring Cloud Functions. What that means is that rather than creating a controller and all the complex HTTP mapping, all I need to do is to just create a small function here. And I am going to use some API to call into say ML. So in that case, I'm going to use the Vision API here. Vision. Okay. Yep, that's good. And just to make sure I have this re-imported so I can refer to its classes. Now, for me to run a function here, right? Remember, Knative, you can run functions or you can run just regular services. In this case, I'm just going to write a quick function. So in Spring, if I want to write a function, I can say, here's the function interface, and the input is a string. I'm going to base64 encode my data, and then the output is a Boolean, which is true and false. And this is going to be called cat not cat. And what I will then return is true or false in the end. Now, because I do want to use some Vision API here, so we have this auto configuration that allows me to just get the Vision template, which is really just a wrapper behind the scenes that allows me to code into the Google Cloud Vision API really easily. And I'm going to try to write this in a single expression. Don't always do this in Java, but because of the time, I'm going to try to do it. So for example, what I need to do is that I need to use the Vision template to analyze my image, which requires a new resource. So this is a byte array resource. Now the input of this is a base64 encoded string. So I'm going to go ahead and decode. So I'm going to get decoder and decode the string input. Okay, so that's the first thing I'm going to do. And then what I need to do is to tell it what I want to detect. So the goal here is to see whether this is a cat or not a cat. So I'm going to do label detection here. And then the result will have the annotation list. This is the result I'm going to get from the API. And then I'm going to stream it. And then if any of the annotation or the result matches certain predicates, then I'm going to return true. So if anything matches, so in this case, I'm going to say if entity annotation dot get score is greater or equal to 0.9, so it's 90% certainty of being a cat, right? So if cat is equal to, in your case, entity annotation dot get description, and that's pretty much it. So that is a function that I can write in a single expression that takes the input of a base64 encoded picture and outputs the string, output the Boolean value. Now, if I want to containerize it, you can of course write a Docker file, but you can also use something like build pack. But my favorite way to containerize a Java application is using Jib. So all that we'll need is to be able to take in a plugin, and then you can just give it the container image that you want to build to, and that is really it. And now I can go to my terminal. Terminal, if you can start my terminal, there we go. And I can say compile, skip test for now, because we have no time. I'm going to say git build, right? And what this will do is to compile my very simple function application, build it with Spring, use Jib to containerize it. There's no Docker file. It pushes directly to my container registry, okay, right here. And now I can actually use it. So if I were to come back here to Knative, I do need that service file, right? Or I can say kn create service, cat not cat, and or service create, I think so. Sorry, service create, cat not cat, and the image is the one I just created right here. And what this will do is to generate that YAML, so I don't have to write it myself. And very quickly, I think we should have cat not cat up and running. If I say kubectl get pod, it's right there. And unfortunately, I think I still have that issue with my command line here, so I can't really curl it. Oh, I can. Oh, good. Well, good news and bad news. The good news is I can curl it. The bad news is actually I have to show you that this works. So, so in that case, I'm going to go to my pictures directory. Here we have a picture of the cat. Okay. I got it from, I forgot where I took this picture. We also have a picture of the dog right there. I took that photo as well. Okay. So supposedly if I do base64 cat, right, or I can cat a cat in base64, right, I'm going to do a post into my cat function, and hopefully the response is true, right? And this is the velocity that you're going to get with this type of platform at a higher level abstraction. Now, just for completeness, before I end this talk, we do need to make sure that the dog comes back to be false, and that was really, really fast. It came back to be false. So we know that this little function actually works really well. Okay. So with that, I'm going to go back to one of the last slides here, and see if you have any questions. But if you want to give it a try, you can go to knative.dev, and then you can find all the installation procedures. The only comment I would add there is that they're using Istio 1.4 as part of the installation. You might just want to skip over that and use Istio 1.6 instead, because it's much easier. Or you can use any of the other service meshes that they have in the documentation. If you want to try a fully managed environment, you can use Cloud Run instead. And if you want to take a collab, James Ward and myself, we actually put together a Knative workshop that you can actually go and try, and provide us any feedback as well. So with that, thank you so much for having me here. And if you have questions, I'm more than happy to help.
Ray, thank you so much. That was great. I think that was the quickest and most successful live coding demo I've seen ever.
It's all pre-recorded. I just played back from the video, right?
Yeah, I was wondering. We do have 5 minutes left in the hour. Those of us who are kind of running this can stick around if there's additional questions. And so I've definitely got some questions. I do want to open it up, though, to anybody who only has a couple of minutes. If you have any questions for Ray, feel free to jump in here. Okay, I will feel free to just jump in or post it in the text chat. I'll be watching that as well. I think what's most interesting about all of this is that, for a while, I think everybody has understood the power of Kubernetes, but is kind of wishing for a higher level API to deal with here, which is really what Knative is, right? I mean, I'm yet to meet a developer who loves, trolling through endless amounts of YAML and configure their application out the door, especially when you bring in additional layers like Istio and things like that. And Knative is clearly an attempt to really simplify that. It's and also kind of build in the best practice and conventions in terms of how to do these things on top of Kubernetes. Where I've found the biggest struggle with providing these higher level APIs really is what happens when you have that user that actually does want that little bit more flexibility, that little bit more power. So, for example, right, we're clearly using Istio here, and that it's doing some things with traffic splitting. What if a developer wanted to say, okay, now I want to actually configure some other stuff in that Istio service mesh, like I want to retry on my service, or I want timeouts and things like that. Are there knobs exposed through Knative to allow you to kind of have that escape hatch to get that extra level of functionality, or is that kind of the trade-off you have to make to get the simplicity? How would a developer do something like that?
Yeah. I think that really comes down to the features of these higher level abstractions, right? I like the fact that you also call this an API, because even in the Java community, just recently, there's a lot of discussions around magic versus explicit function calls, right? So, like for example, in this case, like we have many annotations, or you can make the function calls like that, and they all have their pros and cons. And the bottom line though is that they are both APIs, and just like here, Knative is an API. And so if the API doesn't really allow you to do something, then the API is not fitting your use case, in which case we either need to modify the API, in my mind, right, to accommodate these use cases. So for example, one of the earliest versions of Knative, they didn't really support internal services, right? So every service will be exposed publicly. And I was like, well, that doesn't work for everyone, for most people, right? And there was no way to change it. And this is where the platform and the API doesn't actually support the use case. And so later they added the annotation or part of the API that allows you to specify a service as internal only. So in this case, I would say rather than tuning these things by hand by bypassing Istio or just hand coding Istio directly, because whatever you coded will be ultimately overwritten by the controller to reconcile, and that will never work. So we do need to make sure that some of these use cases are built into the API, either via annotations like min and max instances and internal services, and for these retry rules and stuff. But we do need to find the proper places for it to then trickle down to the actual implementation. Because I think also another problem is potentially that Istio is one of the many choices. So the API would need to be exposed so that the other choices can also have the same fidelity, right? So it won't really matter whether you're running on Istio or Ambassador or many of the other things that they support. It should have the same fidelity. Yeah. As far as I know, right now, it will be very hard to tune these things unless if the API is actually present. And in that case, you may actually need to drop down in terms of abstraction and use the lower level abstraction to construct some of these things. Yeah. Yeah. And another problem potentially is that the more layer that we add on top of Kubernetes, there are more layers of interaction, right? So in case that when something doesn't work, that's why it's really important to understand the actual layering of all of these things behind the scenes, right? So for example, if something doesn't work, it could be any of these things. It could be the fact that the deployment wasn't constructed properly. It could be that the pod is out of capacity, or that the Kubernetes doesn't have capacity to run the pod. It could also be Istio has issues because we are using Istio behind the scenes. So it's also potentially these higher level of abstraction will hide away this complexity. But when things do go wrong, you do need to understand all the layers behind the scenes and troubleshoot them properly. Yeah. So I think there's pros and cons to each.
Absolutely. Thank you for that.
Yeah.
What is the kind of status of the Knative CRDs, the APIs themselves? Are they still under active development? Have they reached like a V1 milestone yet? What could a developer expect in terms of wanting to start using these APIs today and how they may change in the future?
Yeah. If I recall correctly, the serving is definitely V1. So here we can clearly see this is a V1 serving API. So that should be relatively stable. However, the eventing stuff, I would just, I personally is holding off on that one. Don't quote me on this, but just because many of those things are kind of under active development. I'm just gonna wait for it to be more stable. So I think for serving, it's definitely stable to be used. Yeah. And for that, right? Also, like things like Cloud Run and many of the other platforms. They also might be depending on this more stable API as well. And that's what we would expect as part of the GA of Cloud Run, for example. So serving should definitely be ready to be used.
Do all these apps inherit from like a base image?
Do all of these apps inherit from a base image? Yes. For these ones, yes. Because they are Java applications. So it inherits the Java base image, and it can be anything. It could be OpenJDK, Atop OpenJDK. I'm using Serverless, right? For Go applications, if you have something that's statically compiled, then you can use the Scratch base image. So Knative doesn't care what base image you use, as long as you can run your app, it's fine. Yeah.
All right. That's what I was trying to make sure, that there wasn't a Knative base image, so you can use any.
Correct. Yeah. There's no Knative base image you need to use for your app. All of these apps, the only contract is that they listen on a port, and ideally the port is grabbed from the environmental variable. So what Knative contract will give you is the port environmental variable, and your application is supposed to bind to that port, whatever that they give you. And you need to listen on the port. That's really it. And also it's HTTP request. So whether it's HTTP 1 or HTTP 2, both of them are fine, but they have to be HTTP request. So what that means is that you can't run something that listens to a native TCP connection, right? That just wouldn't go through in the load balancers.
What about something like gRPC that piggybacks on HTTP2?
Yeah, as far as I know, gRPC actually works in Knative, as long as the load balancer doesn't catch anything in between. So, for example, with Istio, that's perfectly fine. That should just work out of the box. Yeah.
Oh, that's really cool.
Yeah. 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 So you can schedule. So you can deploy your gRPC services the same way. However, I have to say that in Cloud Run, for example, where it's managed, if you're using Cloud Run on GKE, then it's a regular load balancer, then gRPC will just work. It's Cloud Run, which is fully managed, their load balancer are slightly different. And so you can only do unary request as opposed to streaming, right? So that comes down to the load balancer fidelity itself. Yeah, but if you run Knative in GKE or Kubernetes cluster, that should be okay. Yeah.
And then with the other pieces of the configuration or secrets, does that all get bundled together with that version? So if you roll back a version, would your essentially in the lower layers would config maps and secrets and things like that get rolled back to the prior revision as well?
I don't think so. Yeah, so that's like regular Kubernetes. Yeah.
Got you.
Yeah. So I don't think those get rolled back, and that's why you may actually need to create a new config map. If you use a tool like Customize, the creation of new config map is automated, so you don't have to worry with Customize. However, you do need to garbage collect the older versions of config map that you don't use, and that's the more difficult part. Yeah. That being said, though, I think that's really interesting because some application requires more configuration than the others. It would be kind of nice to make sure that most of the configurations are sent through the environmental variables, in which case your YAML, like here, all of these configurations will be together with that particular revision, and that's where things gets a little easier. However, that only works if you don't have like 100 different parameters to tune. If you have a handful, that should be fine. But in Java applications, sometimes we put in an entire properties file. For that, you probably still want to keep it in a config map. Yeah.
Right. Cool. Any other questions for Ray?
And one note that I want to add is that I started to talk about Knative about 2 years ago, and it was changing very rapidly. And it was for this talk where I actually really went back and to see what has changed and what's still there and what's still around. And I have to say the experience of this whole thing is definitely has gotten a whole lot better compared to 2 years ago. So even then, I'm like more than happier with the outcome of this, and I do recommend it for people to try even more. Yeah, because I think this is the future of these higher level abstractions, whether it's operators or Knative. This is the future of Kubernetes. Yeah.
Oh, fantastic. That was great. Thank you so much, Ray. Really appreciate your time today. We will be putting this recording up on YouTube, and you can see Ray's contact down there. I'm pretty sure he said anybody can feel free to DM him on Twitter at any time. So, send all your technical questions about Knative that way. I think it's a free support contract. But thank you. Thank you very much, Ray. This is fantastic. And thanks, everybody, for tuning in. We will see you again virtually in August.
All right. Thanks for having me here.